Hi, I'm Joe James. Welcome to part 2 of the quadratic equations series. In this video, I'm going to give you a quick introduction to factoring. A factor of n is a number that is multiplied by another number to equal n. In other words, two numbers can be multiplied together to equal 12, then they are factors of 12. So what are some factors of 12? How do we find those? Well, usually the best place to start is 1, because any number times 1 is itself, right? So if we're looking for the factor pairs of 12, let's see, 1 times 12 equals 12, right? Let's see, what's next? Well, 2. If 12 is even, then we can multiply some number times 2 to get 12. So I usually start at 1 and go up from there until I get to the halfway point. So 2 times 6 is equal to 12, right? 2 times 6. How about 3? Well, 3 times 4 is equal to 12. And then 4, well, look, we already did 4. 4 times 3. 5, no. 6 we already did. 6 times 2. So we're at the halfway point. When we get to the halfway point, that's pretty much where it stops because we've already done that. So those are all the factors of 12. That's all the positive factors of 12. They're also negative, right? We could have negative 1 times negative 12, negative 2 times negative 6, and negative 3 times negative 4. I'm not going to write those out, but we know that there are, since 12 is positive, we could have these three pairs of positive factors as well as the same three pairs of negatives. So here's a little exercise. Find all factor pairs of, let's start with 15. Well, again, the first one is the most obvious one, 1 times 15. And then how about 2? 2 times, well, 15 is odd, so there is no 2. 3, well, 3 times 5 is going to give us 15. 4, nope, 15 is not even, so 4 is not a factor. 5, well, we've already done 5. 6, nope. 7, nope. 8, nope. And now we're at the halfway point, so we can stop. So 1 times 15 and 3 times 5 are the only two factors of 15 that we hit. Let's look at number 8 here. Okay, 1 times 8. What else? 2 times, well, 8 is even, so 2 times 4 gives us 8. 3, no, 3 times nothing. 4 we already did, 4 times 2. Now we're at the halfway point, so we can stop. So those are all the factors of 8. Now let's look at 24. Well, 1 times 24. 2 times 12, right? 2 times 12 gives us 24. 3 times 8 gives us 24. 4, okay, 4 times 6 gives us 24. 24 has a lot of factors, doesn't it? 5, no. 6, well, 6 we already did. 7, 8 we already did. And then 9 and 10, no. 12 we already did. So yeah. And then let's see, let's try 18 next. 1 times 18 is our factors of 18. These are factor pairs. 2, okay, 18 is even, so 2 times something. 9. 3, yes, 3 times 6 will give us 18. 4, nope. 4 times 4 is 16, and 4 times 5 is 20, so that doesn't work out. 5, no. 6 we already got, so we can stop there. So those are all the factor pairs for each of these four numbers. And of course, these are just the positive ones, like we said in a previous slide. There are also negatives of all these, right? So negative 1 times negative 24, negative 2 times negative 12, and so on. All of these have also negative factor pairs that are all the same. Let's learn about factoring out. So in the first video, we saw that we can multiply or distribute a number across a binomial. And in reverse, we could divide out numbers from a binomial and put them outside of the parentheses. So that's called factoring out. So in this case, we see that we can divide both of these two terms inside the parentheses by 2, right? They're both even. So let's divide a 2 out of this first term, and we see that that gives us 2 times x. And when we divide a 2 out of the 4, 4 divided by 2 gives us 2. So x plus 2 times 2 is the same as 2x plus 4. All we did is divide each term by 2 and write that 2 outside of the parentheses. Now if we wanted to reconstruct this back to where we started, we would just distribute the 2 across each of these two terms. In other words, multiply it by each of the terms, and we could get back to this. So we've factored a 2 out of this binomial. Let's see if we can factor a number out of each of these binomials. Here we see that we can factor a 5 out of both of these. When we divide the first term by 5, we get 5 times 5x divided by 5 is just x, isn't it? The 5 cancels out. And 15 divided by 5 gives us 3, so plus 3. Okay, how about this second one? What can we factor out of this? Oh boy, there's no number here, is there? There's no coefficient of x squared, so we can't factor a 3 out. But look, they both have x's in them, so we could factor one x out. So let's see, x times, if we divide an x out of x squared, what do we get? Well, we get just x. And then if we divide an x out of 3x, we get plus 3. We took away the x. So just to test that, if we distribute this x across those two terms, x times x is x squared, and x times 3 is 3x. So in the factored form, it looks like this, x times x plus 3. Okay, last one. What can we divide out of this? Well, look, similar to the last one, we see that we can factor an x out because both terms have an x in them. So we can factor an x out. What else? We can also factor out a number. So 3 and 6 are both divisible by 3. So we can factor a 3x out. So if we divide this first term by 3x, let's see, the 3's cancel out, and one of these x's cancels out. So all we get left is just an x in the first term. And then if we divide a 3x out of the second term, what do we get? Well, we divide by 3, we get 2, so plus 2. And then the x's cancel out, so that's all we get. So 3x times x plus 2 is the factored form of this binomial. So if we wanted to reverse and test this, 3x times x would give us 3x squared. Okay, that's cool. 3x times 2 would give us 6x. So that also is cool. So if we applied the distributive property to this factored form, we can get back to this binomial, unfactored binomial form. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.